Assalamualaikum warahmatullahi taala wabarakatuh. My friend, today I'm going to discuss my recent publication with the title Comparative Evaluation of Design Codes for Buckling Assessment of Steel Spherical Shell. This paper is published in the Latin American Journal of Solid Structure. Also, in this video, I'm going to share with you a method for calculating the buckling of steel spherical shell using British Standard PD 5500. This video is suitable for engineers, researchers, postgraduate students, and many more that interested in the field of pressure vessel design. As an introduction, PD 5500 is a widely recognized and respected code in the field of pressure vessel design and construction. It is a British standard that provides guidelines and requirements for the design, fabrication, inspection, and testing of pressure vessels. PD 5500 stands for Pressure Vessel Code PD 5500 Unfired Fusion Welded Pressure Vessel, and it published in the British Standard Institution. In our paper, basically we focus on the comparative evaluation of buckling capacity of steel spherical shell subjected to external pressure using design codes. The first design code, basically we use European ECCS, we use DNV, we use British Standard, which is PD 5500, and then American Bureau of Shipping, which is ABS. All these codes basically is going to compare with the gathered and recorded experiment data with a quantity of 58 sample, all of it. Beforehand, here let me make a brief about PD 5500. As you can see here, in the Y direction is a P over PY ratio, and then in the X direction is a PE over PY ratio. Here you can see a curve that represent a standard format of the PD 5500, and then all the dotted data here is a gathered experimental data from the respected researchers in their existing publication. Okay, so I'm going to scroll down slowly, and here, before we start our calculation, basically we have to, this is some presumption of the spherical shell. Okay, firstly, the spherical shell is being exposed with the external pressure. Okay, secondly, the spherical shell is fully clamped, at the bottom of it. All right. In order to calculate PD 5500 design codes, basically I use Excel file to calculate it. As I mentioned before, in the paper we gathered and record 58 samples of tested spherical shell, the experimental result. So here is the data of it. So in the first sample is a spherical shell that we recorded from Jones. This one is published in Engineering Failure Analysis in the year of 1994. Here's some information we can get from the paper. For example, the geometry of the shell, the radius is a value about 3000 millimeter. So here is the radius, 3000 millimeter. Okay. While the thickness is 4.75 millimeter. So here is the thickness of the shell, which is 4.75 millimeter. And then with this data, basically they're going to calculate the ratio between the radius over thickness. And I already compute earlier in the Excel file, which is 631.58, the value of the radius over thickness ratio. For the material properties, the elastic modulus is 193 megapascal, and the yield stress is 270 megapascal. The Poisson ratio is recorded to be 0.3, and this is all the guided data that we managed to record it from Jones. Okay, now we move on how to calculate the buckling load of the spherical shell using PD 5500. In the first step, what we have to do is we need to calculate the critical buckling using this formula. Okay, using this formula. So I already compute this formula in here in the Excel file. Therefore, it managed to give us about 0.5857 MPa. So we done our first step. So in the second step, I'm going to scroll down to the subsection that focus on calculating the PD 5500. Here it is. The second step is we have to calculate the P yield load. In the in our Excel file, the P yield, that load that going to reach to the yield of the material, is calculated to be 0.855. This one is already computed as shown in the Excel. All right. And in our final step here, if we refer to the to the manuscript, here is the formulation. Of course, we want to make this PD 5500 pressure vessel. We want to get the value of this parameter. Therefore, some simple arrangement is need to be done in order to get the value, and I already done it in my Excel file. And once we compute all the value, we managed to get about 0.172 MPa, a buckling pressure of spherical shell calculated by using PD 5500. At the same time, along with the geometrical and materials values of the spherical shell that we managed to get from Jones, we also managed to extract the real data of the experimental pressure of the spherical shell that been tested. In here, Jones managed to record the spherical shell data to be 0.132. As you can see here, the buckling pressure of the spherical shell calculated by PD 5500 is not much different in comparison with the experimental data. So that's it of my instruction or of my teaching on the method to calculate the buckling pressure of the spherical shell using PD 5500. In this video, I also provide the link for the paper and the link for this Excel file for you guys to study and benchmark. Hope to see you guys soon. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.